Lastly, this question is talking about a sample mean. This absolutely crucial concept in higher level maths, a sample mean. It's a sample of size 16, just extracting all the data as usual and writing it down. So we know the population standard deviation. So state the suitable hypotheses. Obviously this, it's a two-tailed test, not equal to. Find the critical region for x bar. So what you should be thinking is, how is x bar distributed? Now you must know this. How is x bar distributed? If you cannot answer this question, if you cannot answer that, then you just don't understand this topic at all. You've got to get yourself understanding the central limit theorem. This is how sample means of size 16 will be distributed. They will be distributed around the population mean. We don't know it, but we have done a sample. Well, somebody believes it to be 2.5, so that's what we're going to take. And this is the famous variance. Okay, the critical region then is the place where we would reject the null hypothesis. And this is where 5% of all samples are, 2.5% of them to the right and 2.5% to the left. So there's two ways to do this. First way is I'm going to go to distributions, normal, inverse normal, and I'm going to say I want a central bit for 95% of the samples where the standard deviation is the one of x bar, which is 0.1 squared divided by 16 square rooted, so it's 0.1 divided by 4, and the mean is 2.5. We run that, and this is the acceptance region between these two, and so the critical value is on either side. Alternatively, we will go to intervals. Z or T, well, they told us the population standard deviation, and I want a 95% confidence interval where the significance, now what it's saying there is sigma, where the standard deviation is 0.1. I don't need to tell the calculator about the central limit theorem. It knows it. It's just saying, what is sigma? What was the mean of your sample, 2.5? How big was your sample? You just run it, and there is the answer. Now this again is the acceptance region, the region between these two numbers. You would accept the null hypothesis because 95% of all samples, when you find the mean of the sample, 95% of them will fall between these two numbers. And so the critical region is greater than 2.55 or less than 2.45. And the critical values are these two numbers here. Lastly, it talks about a type 2 error. So a type 2 error is the probability of accepting H0 when it is wrong. Now that's a bit wordy. Let's try and convert that into maths. There's two things here. One of them is what does it mean to accept H0? And the other one is, what does it mean that the null hypothesis is wrong? Now a lot of you put this and then said, well, if it's wrong, it is not equal to 2.5. Very sensible. But they've told us what it is. It's 2.6. So they've said, given that it is 2.6, well, that means the null hypothesis is wrong. So that bit is ticked. I can change this to say, instead of saying when it is wrong, I'm going to say when mu is 2.6, which is given. So what is the probability then of accepting H0 when mu equals 2.6? Well, what does it mean to be accepting of H0? Well, I would say we're in the acceptance region. So the question now is, what is the probability of being in the acceptance region when mu equals 2.6? And this all boils down to this. This is the acceptance region. We'd worked it out in the part B. It's the opposite of the critical region. So what's the probability of being in the critical region when our distribution of our sample mean is 2.6 rather than 2.5? Where the mean is 2.6. And so now this is just an NCD question where you type in lower and upper, mean, and this is the variance, so we'd square root that for the standard deviation. Tough question.